Hello students, today we are going to see part 3 of the first chapter, that is Nature of Physical World and Measurement. The contents that we are going to see today are measurement, physical quantities and its types, units and its types, measuring systems, fundamental quantities, derived quantities, and methods of measurement. First, let us see what is meant by measurement. Measurement means comparing a physical quantity with a standard unit. For example, the length of the rubber as say 5 centimeters, or you can give it as 5 into 10 to the power of minus 2 meters. So with the help of a standard unit, that is meter, you are giving the length of this rubber. So this way of comparing a given physical quantity with the standard unit is called as measurement. Measurement is found to be the basis of all scientific studies. Suppose if you are doing some experiment in the chemistry lab, you take a certain amount of the chemical or the salt that is required for the experiment with the help of the measuring jar or with the help of a test tube which has measurements in it. So while doing the experiment, you are following certain measurements. So we can say measurement is found to be the basis of all scientific studies. So while doing this experiment, you are following certain measurements of the chemical, and thus we can say measurement is found to be the basis of all scientific studies. It is also found to play a vital role in our day-to-day life. For example, if your mother wants to get some vegetables from the market, she does so by measuring the weight of the vegetable with the help of a common balance, and she pays the required amount for it. So thus measurement has a very important role in our daily life. Now when we are talking about measurement, we have told that it's a means of comparing a physical quantity with a standard unit. So what is a physical quantity? The quantities that can be measured are called as the physical quantity. And the example for physical quantity you can take as length, mass, time, so on. And the laws of physics are described with the help of the physical quantities. For example, if we consider the Newton's third law of motion, that is every action has an equal and opposite reaction, this law can be explained with the help of the forces that act on the bodies. Types of physical quantities. Physical quantities can be either fundamental or base physical quantity or derived physical quantity. Fundamental quantities are those quantities which are not expressed in terms of any other physical quantity. Examples say length, mass, time. Derived quantities are those which are explained with the help of the fundamental or other physical quantities. For example, if we need to find the area of a square, then it is got by the formula length into length. So for getting this derived quantity area, we have used the fundamental quantity length. Units and its types. When we talk about the fundamental and the derived quantities, there is a chosen standard for expressing these quantities. And this arbitrarily, that is the random method of choosing a standard for expressing the physical quantity is called as the unit. And this unit has been accepted internationally, so the same unit is being followed all over the world. Unit can be of three types. One is a fundamental or base unit. The second one is a derived unit. The third type is called as the supplementary unit. Fundamental units are those units with the help of which the fundamental quantities are measured. And derived units are the ones in which the derived quantities are measured. Supplementary units are, for example, radian and steradian. Next, we'll be seeing about the types of measuring systems. What is meant by a system of units? That is a complete set of units which is used to measure both the fundamental and the derived quantities is called as the system of units. And this system of units is mostly found to be of three types. One is an FPS system, the CGS system, and the MKS system. The FPS system, which is also called as the British Engineering System of Units, has foot as the unit of length, pound as the unit of mass, and second as the unit of time. In CGS system, which is also called as a Gaussian system, the length has the unit as centimeter, mass has the unit as gram, and time has the unit as second. In EMK system, that is in the metric system, unit of length is meter, unit of mass is kilogram, and unit of time is second. Now students, you can see that in all these three systems, the unit of time is the same, that is second. Now let us see what is meant by SI units. SI unit is a metric system and it is also known as the International System of Units. And this has been followed all over the world, and it has been actually developed and recommended by the General Conference on Weights and Measures in the year 1971. This SI unit is found to have some advantages. That is, it is found to be a rational system of units. That is, one particular unit is used to represent only one physical quantity. For example, Newton is the unit of force alone, and this Newton is not found to be the unit of any other physical quantity. The second advantage is the SI system is found to be a coherent system of units. That is, the derived units which are got are from the fundamental or the basic unit and from the supplementary units. So for example, if we are taking acceleration, its unit is meter per second square, which is got from the formula for acceleration, that is acceleration is equal to displacement by time squared. So displacement has the unit meter and time squared is second squared in the denominator. As a result, acceleration has the unit as meter second power minus 2. The third advantage of the SI unit is very large values or very small values can be expressed as powers of 10. So what are the advantages of the SI unit? It is a rational system of units, coherent system of units, and the very large and small values can be represented as multiples and submultiples of the powers of 10. Next, we'll be see what are the fundamental quantities. There are actually 7 fundamental quantities, which are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Their units are represented as, say, for length it is meter, the symbol used is small m. For mass, the unit is kilogram, that is kg. Time has the unit second or s. Electric current has the unit ampere, and as because ampere is got from a scientist's name, the symbol for ampere is capital A. That is, whenever a unit is got from the scientist's name, it in short form it has to be given in capital letters. Likewise, temperature has the unit as Kelvin, so in its symbol is capital K. Kelvin is derived from the scientist's name. Then amount of substance has the unit as mole, which is represented as MOL. Then luminous intensity has the unit as candela, given as CD. Now one by one we will see the meaning of each unit of the fundamental physical quantity. First is 1 meter. Let us assume that a certain amount of light is emitted from a source, and from the time it starts to come out, that is at t equal to 0, till it reaches a time of about 1 by 299,792,458 seconds. That is, starting point is t is equal to 0 till it reaches a fraction of a second. We are noting down what is the distance covered by the light. This experiment is conducted in vacuum. Now this distance is called as 1 meter. So what is 1 meter? It is the length of the path traveled by light in vacuum in 1 by 299,792,458 of a second. So I hope you understood the meaning. Suppose light is coming out of a source and it is found to be placed in vacuum from the starting point, that is t equal to 0, till it reaches a fraction of a second. The distance covered by light is noted, and this distance is called as 1 meter. Next, we'll see what is 1 kilogram. So students, you know, kilogram is the unit of mass. Now, before seeing the definition for 1 kilogram, we will consider a cylinder Before seeing the definition, let us consider this diagram where we have here a cylinder. This is made up of a particular alloy of platinum and iridium, and its dimension has been so designed following an international prototype. A set pattern has been used to design this cylinder. Now, such a cylinder is found to be located at the International Bureau of Weights and Measures at Sèvres near Paris. The mass of this particular cylinder corresponds to 1 kilogram. So what is 1 kilogram? It is equal to the mass of the international prototype of the kilogram, that is a platinum iridium alloy cylinder, which is kept at the International Bureau of Weights and Measures at Sèvres near Paris, France. What is the meaning of this 1 kilogram? We are taking a cylinder which is made up of an alloy of platinum and iridium, and following a set pattern which has been internationally accepted, this cylinder has been made, and now the mass occupied by this cylinder is called as 1 kilogram. Next is 1 second. What is 1 second? We know second is the unit of time, and for this we consider a cesium-133 atom in the ground state. When the atom is in the ground state, there are found to be many radiations or transitions taking place between n is equal to 4 to n is equal to 3. That is, there are found to be radiations occurring between the two levels, that is the hyperfine levels. Let us consider cesium-133 atom which has been placed in the ground state. So at the ground state, radiations are found to take place between the hyperfine levels, and the time taken for 9192631770 radiations is taken as 1 second. So 1 second is the time taken by 9192631770 radiations, and these radiations are found to occur between the hyperfine lines of cesium-133 atom in the ground state. We are going to see what is 1 ampere. Ampere is the unit of electric current. Let us now explain what is 1 ampere. Let us consider two infinite long wires placed in vacuum having a separation of about 1 meters between them. That certain equal amount of current passed through each of the wires. Now they are found to experience a force of 2 into 10 to the power of minus 7 Newton per meter. This amount of current that is sent through the two wires is called as 1 ampere. So what is 1 ampere? It is a standard current which is passed through the two parallel straight wires which are having infinite length, and they are placed 1 meter apart in vacuum, and due to this arrangement they are producing a force of about 2 into 10 to the power of minus 7 Newton per meter of the length of the wire. Next, we are going to see what is 1 Kelvin. Before seeing what is 1 Kelvin, we'll first understand a term called as the triple point of water. That is, this triple point of water is that temperature at which water is found to exist in all the three states, that is in the solid state, liquid state, as well as in the gaseous state. This particular temperature at which all the three states of water is found to be present is called as the triple point of water. And this triple point of water corresponds to about 273.16 Kelvin, or is approximately 0.01 degrees Celsius. 1 Kelvin is a fraction of the thermodynamic temperature of the triple point of water. Next, we'll see what is 1 mole. 1 mole is found to contain about 6.02 into 10 to the power of 23 atoms. Now suppose if you are considering a bowl containing carbon particles, and there is C12 particles, and if we are considering 12 grams of C12, then in this C12 there are found to be 6.02 into 10 to the power of 23 atoms, and this amount is called as 1 mole. So any substance which is having this many number of atoms present in it is called as the mole of that substance. So 1 mole of the substance is that amount of substance which contains as many elementary entities as there are atoms in 0.012 kg or 12 grams of pure C12. Next is one candela. Candela is the unit of luminous intensity. Let us assume there is a source of radiation, a monochromatic radiation is given out, and this monochromatic radiation is found to have a frequency of about 5.4 into 10 to the power of 14 hertz, and the amount of intensity that comes out in that particular direction is found to be 1 by 683 watt by steradian. Now this intensity is called as one candela. So one candela is the luminous intensity which is given in a particular direction by a source which emits a monochromatic radiation of frequency 5.4 into 10 to the power of 14 hertz, and it has a radiant intensity of about 1 by 683 watt by steradian in that particular direction. So till now we have seen about the fundamental quantities, and we had also seen the meaning of each of the unit of the fundamental quantity. Now we are going to see some examples of derived quantities and their units. First we'll consider speed. What is speed? Speed is distance by time. Distance has the unit meter, time has the unit second. So you can write the unit of speed as meter s bar minus 1. Second is acceleration. Acceleration is change in velocity by time taken, or simply velocity by time taken. Velocity or speed has the same unit, that is meter s bar minus 1 divided by time has the unit as second. So we can write it as ms bar minus 2. Then the third is force. Force is the product of mass and acceleration. Its unit can be Newton, or in another way we can write as kg, that is for mass, the unit is kg. For acceleration, it is ms per minus 2. So together we can write it as kg ms per minus 2. So force can be represented either as Newton or kg ms per minus 2. Then next is pressure. Pressure is defined as the force per unit area, and it has one unit as Pascal. The second unit is got by dividing the unit of force, which we have already found here, that is kg ms per minus 2 divided by, for area it's meter squared. So on simplifying we get kg meter per minus 1 s per minus 2. Then fifth example, we have considered work. Work is force into displacement, which can be represented either in joule, or we can take it as, for force it is kg ms per minus 2 into displacement has the unit as meter. So we can write it as kg meter squared s per minus 2. Power is rate of doing work or work done by time taken. It can be given in watt, or for work done we have already found the unit kg meter squared s per minus 2 divided by, for time the unit is second. So we get it as kg meter squared s per minus 3. Then seventh example, we have considered charge. Charge is the product of current and time. It has the unit as coulomb, or you can write as AS, that is A stands for the unit of current, S stands for the unit of time. So AS is also the unit for charge. Now we are going to find what are the different methods used to measure the length. First, let us see what is length. Length is the distance between any 2 points in space. For example, if we are having 2 points, say A and B. So length of AB is the distance between the 2 points A and B, which is equal to 8 centimeter. Now the distance can be given in two forms. Either it can be measured at a larger scale, which is called as microcosm. For example, when we need to measure the distance of the stars or the heavenly bodies, we give it in terms of the light year, where 1 light year is equal to 9.467 into 10 to the power of 15 meter. Or the distance can be measured on a smaller scale, which is called as microcosm. Say for example, if we need to give the dimension of the atoms, we represent it as a smaller value, that is say in terms of micron or 10 power minus 6 meter. There are various ways of measuring the distance. Some distances can be measured by direct method. For example, if the distances are found to lie within the range of about 10 power minus 5 meters to 10 power 2 meter, then we can measure it directly, either with the help of a meter scale, where the meter scale has a range of about 10 power minus 3 meter, which corresponds to 1 millimeter to 1 meter. As an example, we have considered the thickness of a thread. In order to find the thickness of the thread, we wind it nicely around the scale. Now we measure the total length of the winding as L, number of turns given as N. So the thickness of the thread will be equal to total length L divided by the number of turns N. So this is one way of finding the thickness of the thread with the help of the meter scale, which comes under a direct method. Other direct methods used to calculate the distances are by either the vernier calipers or with the help of a screw gauge. So let us now see the range up to which the vernier caliper can be used. The vernier calipers are found to measure a distance of about 10 to the power of minus 4 meter, that is about 0.01 centimeter. The vernier calipers has a least count of about 0.1 millimeter. So how is this calculated? That is, the smallest reading that is measured on the main scale. That is, on the main scale, the smallest reading measured will be 1 millimeter divided by the number of divisions on the vernier scale. The number of divisions normally found on the vernier scale will be 10 divisions. That is from 0 to 10 here. So we have the number of divisions on the vernier scale as 10 division. So 1 by 10 will give you 0.1 millimeter. So this is the smallest value that can be measured with the vernier caliper. The next way of measuring a direct distance is by screw gauge. The screw gauge is found to have a range up to about 10 power minus 5 meter. It has a least count of about 0.01 millimeter, which is got by the formula pitch divided by the number of divisions on the circular scale. So what is one pitch? One pitch is the smallest value found in the main scale, that is 1 millimeter, divided by the number of divisions found in the circular scale, which is about, say, 100 division. So 1 by 100 will give you 0.01 millimeter. So till now we have seen what are the direct ways of measuring the distances. First method is the usage of the meter scale. The second method is with the help of the vernier calipers or the screw gauge. Next we are going to see what are the indirect ways of measuring the distances. That is, indirect method is used if the distance is found to be of a very small value or if it is found to be of a very large value. So the measurement of very small objects can be done with the help of microscopes. Suppose if we need to study the cell structure, the distances between any 2 points is done with the help of the optical microscope. And in optical microscope, we normally use the ordinary visible light, which has a wavelength ranging from about 4000 angstrom degrees, that is corresponding to that of the violet color, to about 7000 angstrom degrees, which corresponds to about red color. And from 4000 to 7000, this becomes the resolution. This is the range within which the optical microscope is found to function. So this is called as the resolution of the optical microscope. So this is the range within which the optical microscope can operate, and so we can say the resolution is found to be equal to the wavelength of the light used. Next method of measuring very small distance is with the help of the electron microscope. In the electron microscope, electron beam are focused with the help of the electric or the magnetic field. This has still higher resolution of about 0.6 angstrom degrees, and as a result, it is possible to study the structure of atoms and molecules in a material with this electron microscope. Still more resolution is found in the case of the tunneling microscope, where again the size of the molecules can be studied. Till now, we had seen about the measurement of very small objects. Now we are going to see how very large objects can be measured. The first method which we are going to see is the triangulation method, and this is usually used to measure the height of accessible objects. Say for example, if we need to measure the height of the tree, then the method used is called as the triangulation method. So let us assume the height of the tree as a h and let its base from the observation point be x. Let its base from the observation point is given as x. Now from the diagram, we can write angle ACB is equal to theta. Also, tan theta can be now given as equal to AB by BC. But what is AB? AB is the height h and BC is equal to x. So from this, height of the tree is given by x into tan theta. Second method of measuring large distance is by parallax method. First, let us understand what is meant by parallax. That is, a shift in the position is called as the parallax. For example, if we need to observe an object at O, first we close the right eye and observe it with the help of the left eye alone, mark its position as L. Next, the left eye is closed and the object is viewed with the help of the right eye. Its position is noted as R. The distance between L and R is given as B, which is called as the basis. The angle subtended by the two readings at the point O is called as the parallax angle, which is given by theta. Now let x be the distance between the object and the point from which it is viewed, that is x. So now we can write B is equal to x into theta, or theta can be written as B by x, from which the distance x is given by B by theta. This parallax method is usually used to measure the distance of a planet or a heavenly body. The third method of measuring the large distances is called as the radar method. This radar method is used to track a plane or an enemy submarine. In this, radio waves are sent from the transmitter. Once after hitting the target, the waves return back and are collected by the receiver. Now, the time taken from its starting point till it reaches the receiver is noted as t. Let v be the speed of the wave, that is the radio wave. The total distance covered from the starting till the end, the total distance covered is given as 2 times x is equal to v into t, from which we can write x is equal to vt by 2. So half of this distance gives the distance of the target or the enemy plane. Next is measurement of mass. Mass is the quantity of matter that is present in a body, and it's actually a property of the matter, and it is found to be independent of temperature, pressure, the position of the object, and so on. Mass can have a range from about 10 power minus 31 kg, which almost corresponds to the mass of an electron, to about 10 power 55 kg, which corresponds to the mass of some heavenly bodies. There are various ways of measuring the masses. That is, it can be either with the help of a common balance, or by gravitational method, or by the mass spectrograph method. So common balance is the one which is normally used by the shopkeepers to weigh the objects. And the next is a gravitational method, which is used to measure very large masses. This formula has been actually taken from the Newton's law of gravitation, that is F is equal to G m1 m2 by r squared. In this, the first mass m1 has been taken as the mass of the earth, and m2 has been taken as the mass of the body whose mass is being measured. The third method of finding the mass is by mass spectrograph method, and by this method the mass of very tiny particles can be measured. In detail, we will be learning about the mass spectrograph in the atoms and nuclei chapter. Next, we are coming to the measurement of time. Normally, time can be measured with the help of the clock, and there are various types of clocks like the electronic oscillators, atomic clocks, and the quartz clock, which we normally used for seeing the time in our houses. So in part 3, we had seen about measurement, then the different types of physical quantities and their units. Then we had seen about the methods of measuring the distances, that is length of object, by direct or indirect method, the measurement of mass and time. We'll be seeing the last part of this chapter in part 4. Thank you.